I would like to talk more on the table spaces and the way the table space is segregated. Before I go there, any questions from previous sessions from anyone? Yeah, there is a small topic left before I go there into the table spaces. That is active databases. There is something called active and inactive databases. When I say DB2 list DB directory, it shows me list of databases exists on the system, exists under this instance called DB2 INST3, right? There is a command called DB2 list active databases. Okay, to explain what is this active, let me go back to this instance architecture. We learned that on a given operating system, I can have instance 1 such as DB2 INST1, DB2 INST2, like that, n number of instances. Within the instance, I can have n number of databases. This is pretty much like a SQL Server architecture. So test DB1, test DB2, test DB3. Similarly, I can have here test DB1, test DB4, like that. If my operating system has, let's say, 500 gigs of memory, so I can restrict at instance level saying, okay, 200 for this guy and 100 for this guy at the instance level. Once I control at instance level, the rest of the 200 GB is left for the OS activities. Once I control like this at instance level 200 and 100, at each database level also I can control, okay, let's give this guy 50 gig and 50 gig. So I can say 30 and 30, whatever is left out, 100 minus 30 minus 30, which is 40 gig, is kept as at the instance level for instance level operations. Right. We also learned that at the instance level we have something called DB2 start and DB2 stop, which is like starting the instance and stopping the instance. When I say stop the instance, it will stop all the databases, right? But what is a mechanism I have to start and stop databases? There is no such mechanism as, okay, let's shut down this database. Like I do DB2 stop, okay, DB2 stop database. There is no such command. Yesterday we were talking about restrictive, right? And we also spoke something about exclusive. You just have to lock the database in exclusive mode if you don't want other users to connect, right? So this is a very important point that we initially get confused. How do I stop a database? There is nothing like DB2 stop and start. You have to lock in exclusive mode, right? Okay. Here sometimes you hear a concept called activate database and deactivate database, active or deactive database. What is active? Which is nothing but memory allocated for the database. Let's say I have assigned 50 gig for this test DB1, right? 50 gig for test DB2, 50 gig for test DB3. When I run this DB2 list active databases for DB2 INST1, I might see only test DB1 as an output, not test DB2 and neither test DB3. Why? The memory is allocated only for this test DB1. Okay, so that is what happening here. When I say DB2 list active databases, even though I have 5 databases within this instance, only one database is showing as active. On what scenarios a database becomes active? When a database becomes active. There are two scenarios. One, we do it manually, or upon first connection request. Sometimes we activate a database manually for whatever the reasons. If we don't want initial overhead of memory allocation on the first request, we do allocate memory manually by just saying that okay, DB2 activate database, let's say test DB4. Now let me terminate from here and run this command. Now what this guy does as part of this activate command is it goes to the test DB4 and checks what is the memory that's supposed to be allocated, and it allocates the memory. Now if you see DB2 list active databases, you see test DB4 here. And the important column here, applications connected currently, which is 0. Even though no applications connected, this database is still active. That is the first scenario, manually activating a database. It's very simple. Activating is nothing but allocation of a memory, allocation of a resources in the anticipation of workload. Right? And the second scenario is you don't allocate anything in prior. Whenever the first request comes, the resources will be allocated. For example, when I say DB2 connect to test DB2. Test DB2 is not active, but I issued a first connection. If I look at the active database, test DB2 becomes active. And you look at the column applications currently connected one. The moment I say remove that application, it becomes inactive. Test DB2 is gone. So how it impacts me, what do I have to do as a database administrator, right? You have to plan how many databases you have within an instance. For example, you have 3 databases, DB1, DB2 and DB3. It depends upon your workload. Do you want to allocate this 50 gig and 50 gig in advance and you just keep those databases as active even though there is no workload? Or you just want system to take care of this memory allocation? I can say 200 gig here at instance level, and I don't allocate individually like this. I just leave it to the DB2 instance to manage memory allocation, because this test DB1 might be heavily used during daytime. Test DB2 is heavily used during non-EST hours, right? So, if you give them equal memory, you might not getting the best. So there is something called automatic memory management, right? It's called self-tuning memory manager here in DB2. You don't specify here at a database level. 99% of the cases, you just leave it at an instance level, right? Let the system manage. If there is more number of requests coming, it will allocate more memory. This test DB1 might get 100 gig. This might have 0 allocated and 0 allocated, because there is no one connected to test DB2 and test DB3. We'll talk more on this self-tuning memory in the process and memory management class, right? But which is most advantageous? That depends upon a DBA who analyzed the workload of a specific environment. Let's say we have four different databases, but three are of no use. One is a major production, right? There is always someone connected to it, so there is no concept of deactivation. But what do we do is we deactivate rest of the three databases. Whenever there is a request comes, that's the time the database gets activated and it gets deactivated automatically. Right. So any questions on this? So this is the story about active and deactive that I could not get a chance to explain yesterday. Okay, let's move on to the next topic that I was talking about, which is called table spaces. How do I list a table spaces within a database? To do that, first you have to connect to that specific database. The moment you issue a connect and the connect is successful, it's like a session. The equivalent term in DB2 we use is application. It says that, okay, this is the database server you connected. This is your authorization ID. And this is the database you connected. Once I connect to the database, I can say list table spaces. The list table spaces will show me the available table spaces. This database is logical and this table space is logical. If you want to see the more information about table spaces, like I said in one of the previous classes, the help is inbuilt. The command help is inbuilt. You don't have to look around. For example, DB2, when I say connect, I don't have any database connection. Let's say DB2 connect to test DB1. DB2 list table spaces. There are 4 table spaces. If you look at the syntax, question mark is one to ask. It says that list table spaces show detail. Let's try list table spaces with show detail command as well. Now what the show detail shows is the extra information than what you see, these 7 lines. This table space ID, name, what type of a table space it is, what type of a contents it is storing, what is the current state of a table space. Right. Now if you look at this output, the first column is incrementing 1. This needs no explanation. The second one is a name, system catalog space. This is nothing but catalog is nothing but metadata. It's for system table space, metadata table space. So we took out some of the important functionality from this metadata table space for performance reasons, like various functions and various commonly used routines, and we put it under separate table space, which is called system tool space. Temporary space is a known thing if you worked on any other database as a DBA. It's for temporary operations. And user space is a default space where you can create new tables and new objects. But the important thing to watch here is a type. This is a database managed space. This is a system managed space. This is database managed and this is database managed. And the second important difference to note here is a content. This is all permanent data. This is all permanent data, permanent, but this is temporary. Because this temp space is for temporary data. This is self-explanatory again. But the important difference to note here is a regular table space. This is a large and this is a large. What is the difference between them? Let's start with understanding of a type. What are the various table space types we can have? There are 2 types of table spaces we can have. One is system managed types. One is system managed. System is nothing but operating system managed, OS managed. And the second one is database managed. So let's talk for some time on this. We have our database system, right? We have a client. So if I talk about a two-tier architecture, client issues a connection to a database, right? Let's say client said, okay, insert this statement, insert this data. The connection comes to the database, then the SQL statement. We have to write this insert data within our database containers or data files, right? Now we have a separate layers beneath DB called operating system, because that's where we install our database. Beneath operating system, we have something called storage. When databases initially started, all the table spaces are system managed, operating system managed. In short, we call as SMS, system managed space. This is a DMS, database managed space. Initially, when databases evolved, everything is a system managed. That means operating system used to communicate. Our operating system is a mediator between database and storage. Whatever is this insert statement 54920 will be written into OS buffers, and the same will be written into the storage buffers. This is one way advantages because a database does not have to worry about writing it into storage. All it has to do is, okay, assign the responsibility to operating system and just wait. So it's very easy, the flexible, but the disadvantages in this system is as a database manager, your database has no control, right? The latency issues, the performance. Over the years, performance became a major item. That's where people walk towards something called database managed. In a database manager, what happens is, isn't it my DB capable to write independently to storage by bypassing OS? Can't my database write directly into the storage buffers by bypassing OS? Yes, the answer became yes over the years. That's where we have a database managed. What are the advantages of database managed? Well, you have more performance because you are avoiding a one layer in middle altogether. But it's more maintenance, right? Database has to worry about the respect to libraries, which is capable to write. But the storage itself are different storage vendors. You have EMC, you have a NetApp, you have Oracle storages itself, you have IBM storages itself. Your database should be compatible to write to all of them, right? Your database binary size increases when you talk about supporting all of them, right? Now, if I go back here, system catalog space is a database managed. When I say system catalog space is database managed, DB2 list table space containers for 0. Whenever I would like to write something here, the database directly writes without operating system involvement. So let's look at the theory. System manager space, the operating system manages. IO is buffered by operating system, right? Table space is automatically extended when needed. That means whatever is the container that gets extended automatically because it's controlled by operating system for the communication. Once you add a container, you cannot drop the container, right? But it is less maintenance, but not optimal for performance. Nowadays, the default option when you create a table space is DMS, database manager space. So let me show you one example of creating a new table space. When I say DB2 create table space DB space 1, this is as simple as just running this command. When I say DB2 list table spaces, I see a fifth table space with ID 4, the name I have given. By default, what you get is database managed. Now you must be curious, where is the storage for this? Where will be the storage allocated? Right? You remember while creating a database, you have something called storage paths. When I say DB2 list DB directory, which database I connected currently? Test DB1, right? This is a local DB path. This has a storage path associated. That is the default storage path it uses, right? You can see this here. When you say DB2 list table space containers for 4, by default it stores here and it creates a directory with T004. This is for system, this is for temp, this is for user, this is for tools, and this is for the new table space I have created. If we just go ahead and create other table space, it will just add one more directory here. This is what I mean by automatic space management. You don't have to mention anywhere in DB2, okay, allocate like this. It takes care of it. But you have to do a very careful planning while creating the database, saying, okay, these are my storage paths, these are my storage directories. Now, I'm not interested in creating a new table space as a database managed, because in this slide we are talking about system managed space. I want to create a new table space which is managed by operating system. Well, that is not a default option. If it is not a default option, we have to explicitly specify like this. But important difference is, let's see if we can see the create table space syntax. You don't have an explicit create table space syntax. With the database itself, you get this table space definition. So you have to explicitly say managed by system, but whenever you say operating system, you have to specify a specific directory, right? Why do you specify directory? You have to specify an empty directory. Why? Because the operating system itself creates a file within it and it manages, right? So if you look at here, create tablespace name managed by system using, this is the storage directory I want to give. For example, since we are here, so let me create a directory. You can create this directory anywhere, right? T000006 underscore SMS. Now let me create table space SMS1 using okay, I missed managed by system. It was not a valid. What is it that I'm missing? create tablespace name managed by system using, or it says the bad container path. Okay, because I need an empty directory here. I did not specify an empty directory here. I need an empty directory. Under test DB1, I need to say what is the directory I created. This is a directory. Now it should go fine. But now who takes the pain of creating system managed space? Anyway, system managed space are not advised right now. Right? But just still in case you want system managed. System managed is not bad, okay? If my database is not performance intensive, I can simply say system managed and I just give one directory. Within that directory, it keeps adding the data files. So system will manage, operating system will manage. Okay, now let's see this DB2 list table spaces. You see the SMS here, which is system managed. When you say DB2 list table space containers for 6, this is as only the type as path. When you look at type for database managed, you see it as a file. The difference, in a system managed, you specify only directory. If you go to this directory, you see a file. So this naming is something that operating system controls. That's exactly the example I'm trying to show here. The type you see as a path. Of course, you can specify multiple directories like this or multiple folders. So if there is a need, to store, let's say 100 gig, 100 gig is equally divided across these 3 different file systems or directories. Right? These paths are not a replication paths. These are RAID paths. Not from the replication point of view, they just share the data. Any questions on the system managed? The database managed is very easy. Like I said, your DB acts as a, your DB does not depend upon any mediator, right? So here instead of directories, you either specify file or raw devices if your OS supports. DB2 manages the input output IO. You can extend containers using alter table space. You have a more control. If you add a container, that is if you add a data file, and if data file is empty for some reason down the line because of space shrinkage or data deletion, you can remove those unused containers from the table space. But you cannot do such thing in system managed. The database managed is ideal for performance sensitive applications, but what it does is it increases your maintenance and monitoring. So how do I create a table space which is database managed? You can say managed by database, like I'm showing in this example, using what is the file and what is the initial space allocation. So, but you don't have to do that something like this managed by database from version 10.1, because from 10.1 version it's automatic storage. Yes, that means it's by default a database managed, right? But just in case if you want to create something like this, you have to say managed by database. So with respect to the types, SMS just uses the directory as a storage starting point, but DMS is a file level. Or if your system support raw devices, you can also use raw devices there. Now this is how the table spaces are classified. based upon the way they are managed. One is SMS, another one is DMS. There is one more category you keep hearing in the latest versions called AMS, right? Which is automatic managed space. Right. Now, what is this automatic managed space? So sometimes people get confused AMS as a replacement for SMS or DMS. So what do we learn? We learn SMS versus DMS. We are now pretty clear on what are the differences between SMS and DMS, right? Now, what is this third category called AMS? Is it replacement or is it another option like SMS, DMS? No, it actually complements SMS or DMS. Right. One standard example I find in explaining this is, let's say you buy a four-wheeler, right? So you if you want to head to office every day on the four-wheeler, you have two different options. One is you drive your own car or you appoint a driver, right? So SMS is like you appoint a driver. DMS is like you drive your own car to work. I'll come back to that question, Manoj, once I finish this topic. So like I said, if you buy a four-wheeler, if you appoint a driver, it's like a system manager because there is a mediator. The advantages of you appointing a driver, you can relax while the driver is driving and you can concentrate on something else because you have a mediator. But the disadvantage is you have to pay driver a salary. DMS is like you drive your own car to work. But whether you appoint a driver, whether you drive your own car, you have something called auto gear model, right? So how you are changing the gears? When your speed increases, do you want to move from 1 to 2, 2 to 3, 3 to 4? Is it happening automatically or manually? That is the concept of AMS. So if I go back to the DMS example here, we are explicitly saying here that this is the file, this is my size, 10 MB. What happens after you reach 10 MB? You want to extend it automatically? Or you have to come here and add one more data file or alter data file? So that's the concept of AMS. Once you reach this 10 M, you can automatically grow. So AMS is not a computation. AMS is not a computation, right? AMS is actually a feature that complements either SMS or DMS. I'll address that question now also. So DBM creates and extends containers as and when needed. So the responsibility of AMS, think it of as an auto gear system, right? Whenever your speed is very high, you will be in a higher gear. Whenever you calm down a little, then the gear comes down automatically. That's the same thing. Whenever you have a more need for space, it allocates space dynamically. Similarly, when you are done with the space, it takes out the containers automatically. Right? So how do I enable this feature? You don't have to do anything from 10.1. This is by default automatic storage. Prior to 10.1, we have to explicitly say that create database name, automatic storage, yes. But this is a default feature. Even when you say create tablespace 1, which is nothing but managed by automatic storage. If I ignore specifying managed by database, managed by system, then it is managed by automatic storage, right? Automatic storage as a DMS. And it takes some time to get used to this terminology, right? But let's concentrate on only the latest version features. Create tablespace name, then it goes to as a managed by automatic storage. But like I said, AMS is just a feature. which complements either DMS or SMS. So you get a DMS table space with the automatic storage feature. Right, any questions? Let me look at there are a couple of questions here. Can we convert from DMS to database managed to AMS? Yes, you can enable the feature, but from SMS to DMS, I don't think you can do straight away. You have to export and import. But I can get you those DB2 documentation on that. There are certain limitations. You cannot just directly move because there is a page size differences, or you can't just directly move from SMS to system manager to database manager just like that. There are some limitations also. But I can get you the document. Let me make a note. So now the question I got here is, I have created SMS, which is as part of my older DB2 design. Now people talk so much about database managed, right? Can I go from SMS to DMS? Just like that. I can simply say alter table space, modify from SMS to DMS. It's not that easy because there are various things comes into picture called page size, and what kind of a data it stores, the table space limits, which is the one I'm going to talk next, right? So it's not that easy, right? But to be honest, I don't remember what are those conditions, other conditions, but I can look at my documentation and get you that information. But this is a very good question. Yeah, and also one more thing is, if I have a DMS without automatic storage, can I convert this into DMS with automatic storage? Right? You cannot do that unless you have enabled this at a database level. Right? Let's say if you are using 9.7 database or instance without automatic storage, first you have to convert database when you are upgrading to 10.1 or 10.5 with automatic storage feature. Without you having this feature at a database level, you cannot just play at a table space level, right? So I can show you this information. I don't think I have a 9.7, but in a database restores, while doing a restore, you have an option to specify that feature. Moving on. So there are storage for database, that is containers, and also DMS table space containers. So there will be confusion where the data is actually stored. What is the confusion here? So there is a storage. Oh, come on, I lost power. There is a question from Manoj that so there are storage for database, that is containers, and also DMS table space containers, so there will be confusion. Okay, so there is nothing called containers at a database level, right? When I say containers, Manoj, it's only containers either at a SMS tablespace or DMS tablespace. There are no containers at a database level at all, right? Database is just a tablespaces. Tablespaces has these containers. So if someone says what is your tablespace layout, when you say DB2 list DB directory, you talk about any of these databases. These database has no containers associated. There is no direct relation between database and container. It has to go through a tablespace. Right. So what kind of a containers you have depends upon what kind of a tablespace we talk about, like SMS or DMS. Is that answers your question, Manoj? In a real-time production, mostly it will be, yes, it's a DMS right now. Yeah, not right now. For many years, it's a DMS. Okay, now let's move on to the second category of table spaces. The first category we have looked at is the way the storage is managed, SMS or DMS. Now the second category is based upon the usage, not really usage, how much data we can store within a table space, right? Before I do that, when I say DB2 list table spaces, we are seeing some information about the table space, the 6 lines or 7 lines. Table space ID, table space name, the type, it's all permanent data, this large table space, right? When you look at DB2 list table space containers for 5, this is the file it created. It's just a flat file at OS, right? This flat file has certain size, right? 32 MB. If I show you here, by 1024 by 1024, it's 32 MB. Why it allocated only 32 MB for this table space? Why not 20? Why not 100? That actually depends upon some default settings. When you say DB2 list table spaces show detail, we are looking for table space ID 5. This show detail option will show little more extra information, such as other than these are top 7 lines, it talks about number of pages it allocated. Like in Oracle, we call it as a block. Here the concept is a page. Same. It allocated for this table space one container, one data file. What is the data file? This is the data file. This data file has 8192 pages, where each page size is 4 KB. Where each page size is 4 KB. 4 KB is a default page size we get in DB2. Now you can do the math here. 8192 pages with 4 KB is nothing but 32 MB. This is nothing but this 32 MB. Right? Now out of these 8192, only 8160 pages are usable. That means the first 32 pages, which is the extent size, that means one extent. Right? You remember our architecture? If I put it in a notepad here at a high level, what do I have? I have a database. A database is a combination of table spaces. Table spaces is a combination of extents. Extent is a combination of pages. The page is a logical thing. So the associated thing at a physical level is OS block. Similarly, table space is a logical thing. The associated physical thing is container. That's exactly what we are seeing here. For this table space, for example, TB space 2, how many containers I have? 1. This container 1 has 8192 pages, right? Out of which the first 32 pages are reserved for header information or some kind of maintenance information. Why only 32? Because 32 is extent size. That means one extent is reserved for overhead. So number of used pages so far is 96. So the free spaces are 8064. So there is one more thing here called preface size. The preface size, you have some kind of a free prefetcher background threads. What they do is when you are reading from this container in a full table scan mode or a full index mode or whatever that full mode, these guys will read ahead pages. So while you are working on this current extent, this guy will go ahead and read one more extent for you even before you actually request. This is for performance, right? The threads are allocated automatically in the backend for your SQL query when it is doing a full table scan on a table. When you are working on like one extent, it will go and get you the next extents immediately. Within you go and your IO thread go and get the request. This is for performance. This preface size is pretty much the extent size. See, of course, you can change all these parameters. Where you can change it? Go back to the database definition. Here, the extent size, the preface size. You also have the overhead and the transfer rate. This is something depends on the OS level, storage level tuning, right? So do you want it to be auto resize automatically, which is default? Yes. What the initial size you want to start? How much data file you want to increase? Do you want to increase with respect to MB or do you want to increase with respect to percents? Right. So what is the maximum size your container will stop at? Right. All these information you can specify at a table space level. Right. But you don't go through all this mess right now. Right. You simply say create tablespace name, and you just control at a high level. At high level means at a database level. Now the space management at a data file level or a container level or a table space level is gone. You just control one switch at a database level saying that these are the file systems. For example, if you see DB2 PD-DB test DB5, we call it as storage groups. You just control at a high level. For this test DB5, these are the storage groups allocated, where each group size is like 1 terabyte and 1 terabyte. When you are running like 70% of storage space, you might go there and put a request for another 1 terabyte and do a rebalancing, right? That's it. That's where you stop managing the space. Okay, why I'm explaining all this, right? So depending upon the number of pages, so how many number of pages I can allocate for this table space, right? Since I have one container, I have 8192. Like this, can I allocate a million pages? Can this table space take million pages? What is the maximum cap, maximum size this table space can handle? That actually depends upon type of table space you use, right? In olden days, it used to be regular. There are two terms here, regular and large. System manager space is always regular. This one is large. System table space is always regular. You can create large Regular you can create system or you can create DMS. So you can have SMS or DMS. But large is only applicable for DMS, right? That's why when I create a system table space here, SMS1, I got only regular table space. Now, what is the difference between regular and large? Depending on the page size, the table space limits. For example, if I am a 4 KB page size, I think SMS can store up to, I think 70 GB table space size, but a DMS can have up to 4 terabyte. One table space when I say the limit. These are the limits. Make sense? So there is this information too, depending upon, you can quickly Google it and say that table space limits page size DB2 LUW. Yep, here I go. There's a little tabular format that explains. Ping you guys in the chat window. So what are the page sizes I can take? 4, 8, 16 and 32. There is no 2 KB here. Depending upon the page size, if I am using a 4 KB, regular the limit is 64. For DMS, it's 8 terabyte. So these are the limits. So that's the story about table spaces, right? So at a high level, we looked at table spaces with respect to the space management, DMS, SMS, and AMS. Table spaces with respect to amount of data they can store, that is regular and large. Regular is for SMS by default, but you can also have a regular. Why do you go for small table space limits, right? In latest versions, you have no necessary for it, but you can still create it, right? But if someone asks, can I create a large SMS? No, you cannot. System manager cannot be large. The large is always reserved for DMS. So along with these two, you also see system temporary and user temporary, right? Application folks know this much better. User temporary, sometimes you have a user temp tables, global temporary tables, and the concept is in DB2, right? By default, you have something called system temporary. Sometimes application developers put forward a request to create a temporary table for storing their user program level global objects. But this is optional, so you won't have this by default. Someone has to let us know to create this. Okay, any questions on these overall table spaces? Okay, so yeah, feel free to ping me in a chat. Let's look at the next topic also, miscellaneous topic, which is the DB2 CLP, right? Which is not from the performance point of view, which is just from the usability point of view, so for better experience of DB2. CLP stands for command line processor. If you look at so far, what we are doing is we are saying that DB2 connected to DB2 create database. We are putting a quotations, right? For every command we type at a dollar prompt, we keep saying that. If you look at my history, we keep saying DB2, DB2, DB2. Can't I avoid using this? Yes. For that, you simply have to say DB2 and enter. Then you enter into an arrow prompt, double arrow prompt, right? This is as equivalent as saying that, connect, right? So list table spaces. You can do all of the things except specifying the DB2 in front because it's taken by default. A flexibility thing. Now this DB2 command comes up with some options, right? You can specify some options which are followed by a specific DB2 command or a SQL statement or a question mark, right? In a question mark, you can specify a phrase or a message or a SQL state or a class code. We have looked at these examples. When you run something here, for example, let's say you get some kind of information here. If you want to understand more about this, you say question mark. So sometimes you see errors here. Before you actually Google it, you can get the information from inbuilt Google, inbuilt documentation. So you can say DB2 and question mark. That's exactly one of the options I'm talking about, DB2 question mark, followed by you can give a specific phrase like create table space or a message, or you can get a SQL state or a class code. What are the information you want to pass after question mark? It tries to search all the documentation and throws you the information. Similarly, you have a bunch of options too that you can use with DB2. I will show you how to execute a SQL file using DB2 command. There are two different modes. Non-interactive mode is the one we were using so far. Interactive mode is you don't have to keep specifying DB2. There are three different terms within DB2 you come across. Right. Once I am within DB2, once I am connected, how do I come out of this? Right. So like I said, every connection in DB2 is a session, is an application, right? Let me say ls. List applications, right? So I have connected to here the test DB1. I can see the connection here. Now the point is I'm connected within the DB2. The first question is how do I go back to the dollar prompt? You can say terminate and it will take back you to the dollar prompt. But what happens with this is when you come back to DB2 again, your database connection is lost. That means this background processes or the application is terminated. But instead of that, you say quit and you come back again, your database connection stays as it is. Quit is just go back to the dollar prompt without touching any of the existing connections. So two important things to note. When I say quit, it does not disconnect the database connection. It does not terminate the backend process. Whereas when I say terminate, it terminates the database connection. It terminates your backend process. There is something else called connect reset, which we pretty much use in a very old and very old DB2 scripts. You can simply say terminate to nowadays. So there was an initial little argument that why to do two things in a one shot, right? It would be calling from some kind of a space management in the backend, right? Let's only disconnect the database connection. Let's keep the backend process, right? In shared kind of an environment. Why to terminate the backend process? So that's why you see people using that connect reset then using the terminate command. Now generally if you talk about standard SQLs, connect to test DB1. Let's say create table T1, column 1 integer, insert into T1 values 549, select star from T1. So this is where you say that, okay, reset the database connection that connected here, and then terminate. So this is how a developer might give us an SQL. So you can run this using DB2 -TVSF. I'll explain you what are those options. Let's watch out how it runs. Right. So during the code promotions, we expect SQL to be coming like this, right? Each of these options has a different meaning. When I say -T, that means there is a terminator in the say.SQL which is a semicolon by default. If you don't specify any terminator after T, it's a semicolon by default. F stands for run the SQLs from a file. V stands for verbose. Whenever you are running a specific line, display on the line what is that you are running. S stands for stop the moment you see error. Don't proceed to the next line at all. Stop the moment you see error. You can say DB2 list command options to see all the available options that DB2 supports. But the ones I listed is like TVS, F, or the some default options. Another important option you can play around is -C. In DB2, by default, everything is auto commit. When I say DB2 connect to test DB1, when I say list tables, I can see the table that I have just created. When I say select star from T1, when I say insert into T1 values, let's say 550, no, you cannot put a semicolon here. You have something here called history, right? History will like a Unix history. You can see the previous commands, right? So by default, this is auto commit. The moment I say insert, any SQL statement is auto commit. You don't have to explicitly commit. Sometimes you don't want this behavior, right? That's when you say this log into DB2 with opposite option than -C. By default, auto commit is on. So how do you do this? You say the DB2 plus C. That means I don't want auto commit. I can still see the data here, but if I open a duplicate session, if I just open a duplicate session, you will see only 2 records because this 551 is not committed yet. So this is another option that sometimes we play around. You can explore the rest of the options. If you say list command options, right, this auto commit is off, right, for this session. When I say list command options in the new session I open, this is on. You can play around. Sometimes you want to say output a specific file. So how do you play around, right? But one important stuff I did not cover much detail was the history. History will show the command number followed by the command you executed. So if I want to repeat this command number 2, I simply say run command or simply R followed by number. I can simply say also H for history or history reverse HR. So if you have a big command, you can also say edit or E. For example, 3. It opens this third command in a VA editor. You can modify it, write and quit. Then it gives an option to want to execute that. Yes, it gets executed. You say commit. So it's a more flexible than SQL plus kind of an environments we have in Oracle. Here, I think SQL plus history is coming somewhere in Oracle 12c release 2 or 18c they're talking about. But this is there in DB2 long time back. Right? That's pretty much about the CLP, right? The CLP history. Any questions on this? Right. So what I do for now is I will skip these catalog tables and talking on the buffer pools right now, the storage groups, right? I will cover them in detail because buffer pools is with respect to the memory. We'll talk more on this in memory and process management. Okay. So I'll stop here for today. What I'll be starting tomorrow is we'll get into I don't think I have a file here, but we get into the data loading and unloading options. Export, import, and load, 3 different commands that drag us to 2 different sessions. Because we've been doing this so much of a theory, so that actually involves the practicals more. We'll just do this data loading, unloading, then look at the backup and recovery. Then we'll come back to these minor concepts, right? Process and memory models. That's when I will cover this storage paths and buffer pools. Okay. So in summary, what did we spoke today? We talked about how do you make a database active or inactive. Then we spoke about table spaces. Then we spoke about DB2 CLP, interactive or non-interactive ways, followed by DB2 CLP's history command. Very small stuff, but table spaces itself is a ocean, right? One of the action items I have is sharing the content on how do I convert from SMS to DMS, the restrictions and the things. I'll share it by tomorrow. Any questions on these topics?